Good evening everyone. I am Sunita madam. Welcome to my class. Today I will discuss few important MCQ question based on the topic periodic and simple harmonic motion. Already in detail I explained the theory class. Those who are not watched the theory class, first better you watch the theory class, understand, then easily you can solve the MCQ questions. Okay. Physics, periodic and simple harmonic motions, MCQ. Okay. Then this is damped, undamped oscillation, everything I explained in the detail. This slides I included once again here. Okay, let us discuss the first question. Okay, let us discuss the first question. The period of a pendulum at a place depends upon the time period t. Period is nothing but t. Time period or period, everything it will be same. The period of a pendulum at a place, it will be depends upon the first option, mass and length of the pendulum. Second one, mass and acceleration due to gravity at that place. Third option, length of the pendulum and acceleration due to gravity at that place. Fourth option, length of the pendulum and shape of the bob. If you know the formula, easily you can answer this question. If you know the formula of a period of a pendulum, then easily you can answer that one. Simple harmonic motion, simple pendulum, everything I explained. See the theory class. Then you know the time period of a simple pendulum, it will be equal to t, it will be equal to 2 pi square root of L divided by G. L is nothing but length of the pendulum. T, it will be equal to 2 pi square root of length divided by G. Here full square root, length divided by G. Therefore, in the case of a simple pendulum, time period it will be depends upon the length of the pendulum, acceleration due to gravity. Therefore, the correct answer for this question is option 3 is the correct answer. Length of the pendulum and G is nothing but acceleration due to gravity. According to the formula, T, it will be equal to 2 pi L divided by G. According to the formula, T, it will be equal to 2 pi square root of L divided by T. If you remember this formula, easily you can answer the question. Okay. Time period is directly proportional. It will be depends upon the length of the pendulum and acceleration due to gravity at that place. Therefore, the correct answer for this question is option 3 is the correct answer. Everything I explained here, I included the notes also. What is meant by simple harmonic motion, then how it will work, everything. Next one, easy question. A periodic motion is defined as, what is meant by a periodic motion? First option, a motion which repeat itself after an equal interval of time. Second one, a motion which does not repeat itself after an equal interval of time. Third option, a motion in which body is under acceleration. Fourth one, a motion in which body is at rest. Very easy question. The question itself, the word itself is indicating periodic motion means a motion which repeat itself an equal interval of time. Therefore, option A is the correct answer. A motion which repeats itself an equal after an equal interval of time. Here I included the definition, everything. Read. Orderly I explained in the theory class. Refer that one. Next question. I informed the timings also, but no one is there in the live. Okay, leave. See the recorded class at least. Next question. The displacement of a particle is represented by the equation y, it will be equal to sine cube omega t. The motion is non-periodic. Second option, periodic but not simple harmonic. Third one, simple harmonic with period 2 pi divided by omega. Fourth one, simple harmonic with period pi divided by omega. The displacement of a particle is represented by this equation. Therefore, whether the motion is what? Let us study periodic motion, then simple harmonic motion, everything. Here the correct answer for this question is the displacement of a particle. Here assume here the particle A is there, here the particle B. Here if this particle is displaced, same particle, consider a particle A, okay. This is the initial position of the particle. This is the final position of the particle. This is the displacement of the particle. This displacement is represented by the equation. Why it will be sine cube omega t. This motion is periodic but not simple harmonic motion. Why it is periodic? Means the change in displacement of the particle, it will be changes with respect to, otherwise it will be repeated with respect to time. Here simple harmonic motion means the object, it will be oscillated to and fro, oscillatory motion. But here the displacement of a particle, it will occur in a straight line, linear motion. This is not a simple harmonic motion. Therefore, the correct answer for this question is periodic but not simple harmonic. That is the correct answer. I included the notes, refer. Next, the circular motion of a particle with constant speed. If the object is moving in a circular path, which type of motion? First option, periodic but not simple harmonic. Second one, neither periodic nor simple harmonic. Third one, periodic and simple harmonic. Fourth one, simple harmonic but not periodic. If an object is moving in a circular path, definitely it will be in the periodic motion. The correct answer for this question is periodic but not simple harmonic. If a object is moving in the circular path, yes, okay, continuously it will be moving in a circular path. Therefore, the object, it will be periodic but not simple harmonic. Why it is not a simple harmonic? Let us study here. Periodic motion is a type of motion where the motion is repeated regular interval of time. That everyone we know. Periodic motion means the motion, it will get repeated for every interval of time. In the case of a simple harmonic motion, it is a type of periodic motion. One of the type of periodic motion is simple harmonic motion, where the object oscillates to and fro about a fixed point. Always remember, in the case of a simple harmonic motion, the object, it will be oscillatory motion. How it will move? It will move to and fro. But here they are given the condition, the object, it will be moving in a circular path. Here the object is not oscillating. Okay, it is not a oscillatory motion. Therefore, here the correct option for this question is periodic but not simple harmonic motion. Then the circular motion of a particle with constant speed is uniform circular motion. Yes, correct. Due to constant speed, the object will cover equal distance in equal interval of time. Hence, the circular motion will be repeated in equal intervals of time. Therefore, it is a periodic. Here they mention constant speed. Constant speed. If an object is moving in the circular path with constant speed, means it is covering equal distance in equal interval of time. Therefore, it is a periodic. But in a circular motion, the object cannot oscillate about a fixed point. Here the object is not oscillating. Therefore, fixed position as it travels circular distance. Therefore, this is not an example of a simple harmonic motion. Okay. Here it is given by the formula. Here extra information I am giving. Listen. Periodic motion, this is the equation. Ft, it will be a sine omega t plus phi. Ft is the position at any time t, position of the particle at any time t. A is the amplitude, t is the time, omega is the angular frequency. Then what is meant by amplitude? Amplitude is nothing but the maximum displacement from the mean position is called as a amplitude. Is when you consider the wave like this, here the maximum displacement of the wave is nothing but a amplitude. Then frequency, number of oscillation in 1 second, like this oscillation per second is nothing but frequency. Time period, time is taken to complete one oscillation is called as a time period. To complete one wave, otherwise to complete one oscillation, how much time it will consider, it will require, that is nothing but time period. Angular frequency, it is nothing but omega, it will be 2 pi by t. This formula also we will use, please see that one. Therefore correct answer for this question is, yes, the question is the circular motion of a particle with constant speed is periodic but not simple harmonic. Why it is not simple harmonic? Because the object is moving in a circular path, it is not moving in a to and fro. And also here they mention constant speed means definitely the object it is covering equal distance with equal interval of time. Don't get confused in the exam, very important one. Next question. Let us consider the next question. Which of the following is simple harmonic motion? Earth spinning around its axis, ball bouncing between two vertical walls, third one, wave moving through a string fixed at both ends, particles moving in a circle with uniform speed. The correct answer for this question is wave moving through a string with a fixed end. This is also one of the example of a simple harmonic motion. Earth spinning around its axis, it will be in the circular path. Therefore, this is only the periodic. First one. Ball bouncing between two vertical walls. Bouncing of the ball, periodic. Particles moving in a circle with uniform speed. Last question I explained. No, these all the three are periodic. Wave through which a string fixed at both ends. See, both the ends are fixed. Consider here you are having a string like this. This string it will be get oscillating like this. This is the example of simple harmonic motion. Therefore option 3 is the correct answer. Don't get confused between simple and periodic motion. Okay, simple harmonic motion and periodic motion. Let us move to the next question. A plane progressive wave is given by y is equal to 25 cos 2 pi omega t minus pi x. Then the amplitude and frequency are respectively. What are the amplitude and frequencies are respectively? Consider in the case of a simple harmonic motion is a special type of periodic motion or oscillatory where the restoring force is directly proportional to the displacement, act in the direction opposite to that of a displacement. Restoring force is directly proportional to the displacement, opposite direction. Therefore here minus sign is there. What is meant by restoring force? Simple harmonic motion, everything I explained in theory. Please see the theory class, then come back. It will be easy for you. Okay, to answer this MCQ question, when you watch the theory class, it will be easy because in detail I explained all this concept. Okay, where K is the restoring force, X is the distance from the equilibrium position, F is the force it experiences towards the mean position. Here the example for this one is motion of an undamped pendulum, undamped spring mass system. What you have to remember, in the case of simple harmonic motion, the restoring force is directly proportional to the displacement act on it. Here consider this is the simple pendulum. You know you are having two extreme and mean position. These are the maximum or extreme position. These are the maximum and extreme position. This one is the mean position. When the pendulum, when it will reach the maximum, it has to come back to its original position. Okay, then the force it has to act on this one in the opposite direction towards this one. Therefore here negative sign is there. Okay, in the opposite direction the force it will be acting to bring this bob to the mean position. This force we will call it as a restoring force. That one only I explained. Okay, then remember the formula, it will be very important for you. Then consider the equation here. Simple harmonic motion is represented by x, it will be a cos omega t plus phi. Here a is amplitude, omega is angular frequency, x is displacement, phi is phase constant. Everything you have to remember, because in MCQ question what is meant by phi they will ask, what is meant by x, what is meant by omega, everything they will ask. A plane progressive wave is given by this equation. They are given, general equation is x is equal to a cos omega t plus phi. In the question they are given y is equal to 25 cos 2 pi t minus pi x. Compare equation 1 and 2. Consider this is equation 1, this is equation 2. Then a it will be equal to 25. Yes, you can compare this one, this one. Then omega, where is omega? Omega, this one it will be equal to 2 pi. Then you know frequency it will be equal to omega divided by 2 pi. Substitute the value of omega in place of omega. Consider 2 pi divided by 2 pi. Both it will get cancelled. Then your answer is 1 hertz. Everything you have to remember. You have to remember the simple harmonic motion. It is represented by this equation. Otherwise consider as the expression x it will be equal to a cos omega t plus phi. Phi, what is meant by phi? Phase constant. That one remember. Then compare both the equation. Then amplitude it will be 25. Then frequency, you know the formula omega divided by 2y. Substitute the value of omega 2 pi by 2 pi. It will be 1 hertz. Therefore the correct answer for this question is 25. Amplitude is 25. Then frequency is 1 hertz. Very simple question, easy question. Yes, let us move to the next question. Okay. A 4 kg block is attached to a spring of spring constant 400 nanometer. Calculate the time period of the oscillation. Remember the formula, oscillation of a spring, W it will be omega, omega it will be K divided by M. These two formulas very important, listen. Remember. Then here they are given. Okay, I will explain. Okay, look, I will explain here. Consider this diagram. Then here this is the string. It's represented by a constant K. Then this is the mass of the box, wooden box. Otherwise what they are given, wooden box, or once again I will read the question. A 4 kg block, what is the mass of that block? Mass it will be 4 kg is attached to a spring of spring constant. Spring constant is K, that is 400 nanometer. Calculate the time period of the oscillation. Okay, here I wrote the diagram. Here I explained theory, everything. Remember this one. This is the spring. This is the spring constant. This is the mass of the wooden box or metal or wooden box. Consider it will be 400 nanometer. Then calculation, it will be here. I will show here. See, t, it will be time period. It will be 2 pi divided by 2 pi into m divided by k. Then write 2 pi as it is. Mass of that wooden box, otherwise mass of the box, it will be 400. K is the spring constant, that is 400. Then it will be 2 pi. Then 1s are 100s are 4 1s are 400s are. Then 1 by root 100 is nothing but divided by 10. Correct? No, into 1 by 10. Then it will be equal to t, it will be equal to 0.2 pi second, because 1 by 10, otherwise 2 by 10 is nothing but 0.2 pi second. Otherwise we will get 1 by 5. 1 by 5 is nothing but 1 2 1s are 2 5s are 1 by 5 is nothing but 0.2 pi seconds. Yes, calculation you can do here. Then you have to remember here, this is the when the time period of the simple harmonic motion of the spring mass system is given by 2 pi, it will be square root of m divided by k. I will write once again here because okay, consider this is the spring. Then here consider this is the spring is attached to one wooden. Then here one box they kept. Here what they are given, 4 kg block. This is the block having 4 kg. Then is attached to a spring constant is given k. It will be 400 n divided by m. Calculate the time period. You know time period, it will be 1 by 2 pi square root of k divided by m, or m by k or k by m. Once again I will check. M by k, I think. K divided by m divided by 1 by 2 pi. Why I am writing the 1 by 2 pi, 2 pi. Otherwise reverse also you can consider, but 2 pi m by k consider. Then here I will erase this one. Root also you can consider, but better consider this way only. 2 pi m divided by k square root. Then 2 pi write as it is. M value is 4. Then k value is 400. Then 4 1s are 400s are 1 by 100 is nothing but square root of 1 by 100 is nothing but 10. This is nothing but 0.2 pi. Therefore correct answer for this question is 0.2 pi. I included the theory part. I already explained in the theory, but once again revise, it will help when you are solving MCQ problem. Once again if you revise the concept, it will be helpful for you. Okay, total energy of a particle performing simple harmonic motion is first option maximum at extreme point, minimum at mean point, the same at every point, minimum at extreme point. What is the correct answer for this question is, I included the formula here. See here, potential energy of a body performing simple harmonic motion. This is the formula. E, it will be equal to of m square omega square x square. Then this is the kinetic energy of a particle, otherwise body, executing simple harmonic motion. E, it will be equal to of m square omega square bracket a square minus y square into a square minus y square. Consider this is the wave, only one wave I consider here. When you are talking about the energy, the total energy total mechanical energy always remain constant. It is equal to sum of the potential energy plus kinetic energy, where total energy of a particle performing simple harmonic motion at every point it will be same, because always total mechanical energy it will be equal to sum of the potential energy plus kinetic energy. According to this explanation, the total energy of a particle performing only simple harmonic motion, it will be constant everywhere. Therefore, the correct answer for this question, only in the case of simple harmonic motion, not for periodic, the total energy of a particle performing simple harmonic motion is always the same at every point. Why means total energy it will be equal to sum of kinetic energy plus potential energy. This sum is always constant. Energy is always constant. Why means energy is always constant. Why? Because once kinetic energy decreases, potential energy it will be increases. If kinetic energy is increases, potential energy is decreases. But total energy of the system, it will be same at every point. It will be same at every point. Therefore, option 3 is the correct answer. That's why I included even the wave diagram also. Sometime you can observe here, for this wave, potential energy it will be more at some point, kinetic energy it will be less at some point, but total energy at each and every point it will be constant. Next question. Next question. The equation of simple harmonic motion of a particle, that is y is equal to a sine 4 pi t. Find the displacement of the particle at 1 divided by 24 second from the nearby extreme position. Let us calculate very easy one. They are given, better I will write here. I will write down only. Y it will be equal to a sine 4 pi t. They are given in the question. Then they are given the value of t is 1 by 24 second. In place of t, substitute the value. A sine 4 pi into the value of t is 1 by 24. Then a sine, cancel here, 4 ones are 4 6 are. This it will be equal to pi by 6. Then a sine pi by 6, 180 divided by 6 is nothing but sine 30. Pi value, substitute pi by 6 is nothing but what? 180 divided by 6 means 6 ones are 6 threes are. Then 30 degree. Then sine 30 it will be how much? Sine 30 degree it will be 1 by 2. Here a into 1 by 2 is nothing but a divided by 2. Then one more, the displacement from the nearby extreme, it will be equal to a minus y. You know the value of y, a minus a divided by 2. Take LCM, 2 minus a by 2a minus a by divided by 2. Your answer is a divided by 2. This is the correct answer. Very easy question. Here they are given the value of t, time they are given here. Then time it will be equal to 1 by 24. Substitute here. Both it will get cancelled. You will get pi by 6. Sine 30 degree it will be 1 by 2, a by 2. Then you know displacement from the nearby extreme point, a minus y. That one you have to remember. Substitute the value of y, a by 2. Take LCM, you will get a divided by 2. What is the correct answer for this question is a divided by 2. If you see the question, it will be looking like it will be difficult, but easy question. Okay, this one very easy question. Tell me, those who are there in the live, at least listen. Next one, if simple harmonic motion is represented by x is equal to a cos omega t plus phi, what is mean by omega? Omega is nothing but, phi is nothing but phase constant. Angular frequency, a means amplitude, x means displacement. What is mean by omega? Omega is angular frequency. Displacement is here x, amplitude a, phase constant phi, correct no? Then angular frequency is nothing but omega. Remember, out of 4 any one they may ask in the exam. Next one, the time period of a simple pendulum inside the satellite orbital Earth is. What is the time period of a simple pendulum inside the satellite orbiting Earth? The satellite, it will be revolving around the Earth. Inside the satellite, what is the time period of a simple pendulum? Very interesting question. First option 0, 2t, t or infinity. Let us discuss here. You know the formula, time period of a simple pendulum, t, it will be 2 pi L divided by g. L is nothing but length of the string, g means acceleration due to gravity. You know that t is directly proportional to length, inversely proportional to g. An artificial satellite orbiting the Earth, net gravity, it will be 0. T directly proportional to L by 0. 1 by 0 or anything by 0, it will be infinity. T, it will be equal to infinity. Correct no? The correct answer is infinity. Why it is infinity means g value, it will become 0. When anything by 0, it will be infinity. Therefore, time period, I will write once again here. You know the formula, t, it will be equal to 2 pi L by g. Okay, substitute here only 2 pi, we don't know L, g at simple pendulum inside the satellite, artificial satellite, that it will be revolving around the Earth means gravitational force, it will be 0. Anything by 0, it will be infinity. T, it will be infinity. Easy question. Next question. The length of a simple pendulum is increased than the time period it will be. When length is increased, what is the, when length is increased, you know the formula, t, it will be equal to 2 pi L by g. What they are telling, the length of a simple pendulum, this L is increased. If this is increased, then what is the change in the time period? Automatically it will be increases. Yes, according to the equation directly you can conclude it will be increases. The length of a simple pendulum is increased, then the time period it will be increased, because both are directly proportional to each other. If one quantity is increases, another also it will be increases. I am not reading the option, that you can do it. A child swinging on a swing in sitting position, stand up, then the time period of a swing will be. First option decreases, remains the same, increases, none of this. Very interesting question. I will explain with the diagram. Here consider this is a swing. Okay, thread is there. If this girl is standing, okay, when she is sitting, standing, then what is the change in the, what they are asking in the question, what is the, then the time period of the swing will be, they are asking the time period of the swing. you know the time period of the swing is, the swing girl can be considered as a simple harmonic pendulum is T, it will be equal to 2 pi L by G. The length of the simple pendulum is equal to the distance from the point of suspension to the center of gravity, Cg of the oscillating body. Center of gravity of the oscillating body. Center of gravity. Here consider this picture. From here to here, this is the center of gravity. According to this picture, this is the center of gravity. Here Cg. This is the center of gravity. Then this is the length of the string we can consider. When the girl is sitting, the full length of the thread is nothing but length of the pendulum or length of the string you can consider. When that same girl, when it is standing, her body midpoint is the center of gravity. Up to the center of gravity we will consider the length. In the first case the length it will be more, in the second case the length it will be less. According to the equation T, it will be 2 pi L by G. In the first case the length it will be more, okay, then time period also it will be more, because length of the string is directly proportional to the time period. In the second case T, it will be equal to 2 pi L by G. Compared to the first one, here the length it will be less, decreases. Then time period also decreases. Then period it will be decreases. What is the correct answer for this question is it will be decreases. Okay, I will explain once again. A child swinging on a swing in sitting position and stand up, then the time period of the swing will be. First what will happen? The girl, she will sit, then she will start swinging. When she is sitting, this is the center of gravity of the girl. Then this is nothing but length of the string. When length of the string is more, time period it will be more. Instead of sitting, immediately she will stand. When she will stand, this is the center of gravity, then this is the length of the string. Then here in the second case the length of the string is decreases, then time period also it will be decreases. Okay, very easy question, but like this tricky question definitely they will ask in the exam. When you will see, don't get confused. Okay, please read the recorded class. Those who are not there in the live, these are the important questions I am framing, I am explaining. Equation of motion of a particle is given by A, it will be equal to minus bx, where A is the acceleration, x is the displacement from the mean position, b is any constant, then the time period of the pendulum it will be equal to. Let us do the calculation here. Option 3 is the correct answer they are telling. They are given equation of motion, they are given A, it will be equal to minus bx. Okay, where A is the acceleration, x is the displacement from the mean position, b is any constant. Compare this equation with our general equation. Compare it with the equation of acceleration minus omega square x. From this omega square it will be equal to b. Compare equation 1 and 2. Then omega it will be equal to omega square it will be equal to b. Minus minus sign it will get cancelled. Omega it will be square root of b. Then you know the formula, T it will be equal to 2 pi by omega. In the case of omega, substitute the value 2 divided by 2 pi by root b. This is the correct answer for this question. Very easy question. Already they are given the equation A is equal to minus bx. Compare this one with our general acceleration equation. A it will be minus omega square x, then omega square it will be b when you compare these two equations. Then omega it will be root b. They are asking the time period. You know the formula, 2 pi by omega. 2 pi, substitute the omega value, 2 pi by root b. 2 pi by root b. Option 3 is the correct answer. Practice 1 or 2 times, revise the question 2-3 times, then easily you can answer. Okay, a body is said to be move with simple harmonic motion if its acceleration is. If a body is said to move with simple harmonic motion, what about its acceleration? Always directed away from the center at the point of reference. Option 2, proportional to the square of the distance from the point of reference. Option 3, proportional to the distance from the point of reference and directed towards it. None of this. Proportional to the, let us discuss the answer first. Acceleration, you know, force of a simple pendulum, simple harmonic motion, F is minus kx. In a simple harmonic motion, restoring force is directly proportional to the displacement. This is very, very important. Restoring force is directly proportional to the displacement. Compare this one with acceleration. You know, F is equal to ma. Then A, it will be F divided by m. Substitute here acceleration. In place of F, substitute A. F is equal to ma. I will write here ma. It will be minus kx. Then I will keep only acceleration minus k divided by m into x. You can consider, yes. Where a is the acceleration, x is the displacement of the system from its equilibrium position, m is the mass, k is the constant of acceleration with the system. Then what is the correct answer for this question? Proportional to the distance from the point of reference directed towards it. Yes, this one is proportional to the distance from the point of reference directed towards it. Option 3 is the correct answer. Okay, once again I will explain the question. The body is said to move with simple harmonic motion if its acceleration, what about the change in acceleration? Acceleration, it will be equal to, you know the formula, minus k by m into x. Okay, then now see the option, third one. This is proportional to the distance, directly proportional to the distance. This is the distance, x is the distance, correct? No, directly proportional to the distance from the point of reference. Yes, this from the point of reference directed toward it. Yes, directly, that acceleration, it will be directed towards the force. That is the correct answer. Next question. If simple harmonic motion is represented by x, it will be a cos omega t plus phi. What is the meaning of phi? Angular velocity? No. Displacement, amplitude, phase constant. Option 4 is the correct answer. So many times I told amplitude is a, x means displacement, angular velocity w, then phi is phase constant. Easy question, very, very easy question. This is the last question, today's last question. A simple pendulum has a time period t. If the mass of the bob is made 1/4, then the time period of the pendulum will become, mass of the bob is given m2, it will be 1/4 of m1, they are given in the question. Then time period, it will be 2 pi by lg. Since the time period of the simple pendulum does not depends upon the mass of the bob, in this one we don't have we don't have the constant m, we don't have any alphabet m, correct? No. So the change in mass of the bob will not affect the time period of the pendulum. You know the time period, you know the formula, t, it will be equal to, therefore option, which option is the correct answer? Option 4 is the correct answer. I will explain, don't worry. T, it will be equal to 2 pi L divided by G. Here A simple pendulum has a time period of t if the mass of the bob, is given. This bob, it will be 1/4 of the original one. Then what is the time period of the pendulum will become? Time period of a pendulum, it will be depends upon the length and it will be depends upon the acceleration due to gravity. Already we know. Directly depends upon the length and acceleration due to gravity. But this t does not depend upon the mass. Does not depends on mass. When there is a change in mass, it will not affect t. It will not at all affect t. It will be remains same. Very interesting question. Okay, in the case of a simple pendulum, this time period it will be depend upon the length and acceleration due to gravity. It does not depend upon the mass. We don't have any m here, correct? No, in this formula we don't have any m. Then therefore t is independent of the time period of a simple pendulum is independent of the, it will be independent of the mass of the bob. Okay, I think everyone you understood. Few important MCQ questions based on the concept periodic and simple harmonic motions. Everything I cleared. I covered all the concept. Please, I am requesting those you will watch the recorded class. Please watch carefully. Definitely it will helpful for your upcoming exam, whether it is TET, CTET or any competitive exams. It will be very important. Physics concept, whatever you are preparing for competitive exams, it will be very helpful. Then forward my videos to your friends. It will help for them also. Okay, thank you everyone. Thanks for watching my class. Please keep reading, read well.